Welcome to Algebra 2, Semester 1, Unit 6, the final little packet to go through before the final exam. You guys, really proud of you. Just keep studying. This packet, I think you'll be actually just excited over how much you really know when you don't make it harder than it is. Okay, take it step by step. These problems look intimidating. Remember, you are mathematicians, you are scholars, you can do this. So, what is the remainder when we divide this? Remember, we choose to do synthetic division when at all possible. Synthetic division we've done a few times, in fact quite a few times. So we take x minus 5 equals 0 to see what the x root would be, which is 5. Now we divide that 5 into, remember, we want to go down in order on our exponents. We have x cubed, and we should have an x squared, then an x to the first, then a constant. Now let's check our numbers. We have an x cubed. That's where I knew how to start. So -4. We have an 80 for the x, and we have a constant of a -150. Now we need to make sure and bring down a 0. Okay? So we drop the -4, multiply by 5, that would be a -20, add 0 and -20. -20 times 5 would be a -100. We add, that would be a -20. 5 times -20 is -100. -100 and -150 would be a -250. It is asking what the remainder is. Your remainder is always that last number, and so that would be A. Nothing more that you need to show on that one. It's obvious why the others are wrong. They're the wrong number. Okay? Next one. They say we can use synthetic. Let's use it. Again, we find the root, which is x equals 16. We start at x squared, so we have an x squared value, an x value, and a constant. Looks like we aren't going to need any zeros for this one. We put the 16 out here, 2, -33, and 16. So we drop the 2. Multiply by 16, add, we get a -1, multiply, -16, get a 0. That means that this is a factor. So we have x minus 16 as one factor. Our other factor, because we're dividing, we've gotten one less in our exponent there. Watch the Unit 6 notes if you need help with that. So instead of going with x squared, we'd have just an x. So we have 2x minus 1. They're asking for the other factor or the quotient when we divided by this, so it would be that. Okay, this one has a 2x plus 1. This one has a remainder, that one has a remainder. Okay. Next problem, it says given x minus 9 is a factor, so that means it would divide in with a 0 as the remainder, just like that one did. Of this polynomial, what are the remaining factors? Well, let's go ahead and take x minus 9, find the root. We would get x equals 9. Let's go ahead and divide it here. So we have x cubed, x squared, x, and a constant. No zeros needed, so we're going to go 16 minus 144 minus 81 plus 729, and we're going to be dividing that by 9. Okay, we drop down the 16, and when we drop down 16, we multiply by 9, we get 144. That will become 0 when we add it. 9 times 0 is 0. That makes negative 81. 9 times negative 81 is negative 729, which we expected to have that 0 because this is a factor. We have one less on our exponent, so that's 16x squared minus 81. There's no x value. So our factor is 16x squared minus 81. Hopefully you're looking at that saying, hey, that's a difference of 2 squares, because it sure is. We have 4x squared minus 9 plus 9. Now, if you look up above, you don't have that answer. You've got 4x minus 9, 4x minus 9, 4x minus, it's nowhere, except for right here as a plus. We know that that's a negative. So we look for our own mistake and we say, oh, it wouldn't be x squared because x squared times x squared would be 16x to the 4th. So we back that back down to being just an x. Now can we find our answer? We do find it right here. Problem with this one, they have them both being negatives. Problem with this one, they don't have both of them. And the problem with this one was the plus. Okay? Next one. They're wanting to know the end behavior. Remember we talked about end behavior on a positive even, looked like this. End behavior on a negative even, looked like this. And that's just generally. Positive behavior on an odd, I'm just using the smallest even and odd, looks like this. And negative odd looks like this. We look at our front leading terms because that's what will determine whether it's an odd or even. 3x to the 5th times x squared would be 3x to the 7th. X to the 7th is an odd, and it's positive. So we come back down to our positive, and we say as f of x, actually I should start the other way, I'm sorry. As x goes towards the negative over this way, as x approaches negative infinity, f of x, or the y value, approaches negative infinity. It's going down. See if we can eliminate just off of that. X approaches negative, f of x approaches negative, so those are right. Negative, positive, that one's out because of that positive. Negative, 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 positive, that one's out. Now, as x approaches positive, we have to look at this now. As x approaches positive infinity, that means going this way, the y is, or the f of x is going to positive infinity. So we look back here, as f of x, or as x goes to positive, f of x goes to positive, this one has negative. So that's correct. Okay? State whether the function is increasing or decreasing. We talked about this way back in Algebra 1, if you had me. When a line goes up to the left, it is a negative slope. We talked about how it's depressing. It's getting lower as it goes, or it's decreasing. So anywhere that you see the line going that way, it is decreasing. Okay? When you see the slope going to the right, it is positive or it is increasing. Okay? So now we have to kind of see where it's switching here. That point right there is a switch between. That is at 1, 2, 3, 4, -4. So we should see a -4 in here, showing an increase and a decreasing. The next spot that it switches is at 0, and here at -8. So it's decreasing from infinity, negative infinity, to -8. It's increasing from -8 to -4. And it's decreasing again from -4. See, this is going this way. From -4 to 0. This is decreasing. But then it increases from 0 to positive infinity. So now all we have to do is match up which ones work. Decreasing, they have positive and negative infinity. That's definitely wrong. It's out, never increasing. Negative infinity, we don't have that on our, oh yes we do, negative infinity, but then it doesn't have the -4, 0, so that one's out. Decreasing again, it doesn't have -4, 0. That one's out. Oh, and this one does have those and those, so it's got all 4. Okay? Go back to Unit 6 if you need to study decreasing and increasing. Maximum, you know, max is the frown. And min is a smile. So we've got a relative minimum right here at +2. This is a min. We've also got a relative minimum at -1. Let's see if we can eliminate things just with that. So minimum, -4, 4, that's not going to work. Minimum, -1 and 2, that one works. Minimum, 0, that one does not work. Minimum, -1, that's only one of them, we need the other one. So just with that, we can do that. This would be a relative maximum. Which polynomial is graphed below? I look at the zeros because when we factor these and find the root, set them to 0, then we're finding the zeros on the graph. This 0 is x equals 0. This one is at -1, x equals -1. And this one is at 3, x equals +3. So we need 3 roots. We've only got 2 here. That's a problem. It doesn't have an x. Mark it out. This one has 3. This one has 3, and this one has 3. So let's go ahead and take these to where they would be. X equals 0 would just be an x in the polynomial. X equals -1 would become x plus 1, set to 0. And we can eliminate right there, probably, off of everything. Let's go ahead and do the x equals 3. That would be x minus 3. And now you can see C is our best choice. Okay? Circle what is not correct in the others. Okay, next set of problems here. Which of the following is not a possible rational root? Go to Unit 6 and study the rational roots. It's a fraction, a ratio of the roots or factors of the 3, which would be plus or minus 1 and plus or minus 3. And then on the top, it has all the possible factors of 8. So we'd have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So we want to look at all the possibilities here. Could we have a -1? Well, we certainly could. We could have 1 over 1. That would be a negative 1. So that is a possible. We're looking for the ones that are not possible. Could we have 4/3? Sure enough, right there's 4/3. We could have that. So that's out. We could have 8/3. So that one's out. The only one that we could not have is 6. Nothing would reduce to be equal to 6. So that one's the one that is not a possibility. Okay, use synthetic division to find the 2 remaining real solutions. So we bring 5. And we have x cubed, x squared, x, and a constant. Looks like we won't need any zeros in there. So we have 3, negative 35, 128, and negative 140. Drop the first, 3, 5 times 3 is 15. Add, negative 20, multiply, be a negative 100. Add, we get 28. Multiply, and we get positive 140. And as expected, we have a 0 remainder. Now this becomes 3x squared minus 20x plus 28. When we try to find our factors, it would be 3 times 8 is 24, 74. I'm sorry, 64. 3 times 8 is 24. Carry the 2, 6, 7, 84. And 2 factors that would multiply to be a positive, add to be a negative, negative, negative. I'm going with 14 and 6. That would be 84. Okay. So we continue factoring. 3x squared minus 14x minus 6x plus 28. Factor out an x. 3x minus 14. And over here we copy paste 3x minus 14 and subtract 2 on the front. So we would have 3x minus 14 times x minus 2. And then we also have the x equals 5. But these are the 2 new roots that we're looking at. Set each of them to 0. 3x minus 14 equals 0. Would add 14 to each side. 3x equals 14. X equals 14/3. D is out, but the other possibilities are all standing strong. Now we need to find our other root, which is x minus 2 equals 0. X equals positive 2. That one had a negative 2. This one has a 6. This is our correct answer. Okay, next situation here. They're asking us to use the graph to help solve the equation and find all the roots of the function. Well, the one function that I can clearly see is a 3 there. X equals 3. So I would choose to use synthetic division on this. I would go 3. I have an x cubed, an x squared, an x, and a constant. My x cubed is 1, x squared is negative 3, x is 4, constant is negative 12. Drop down the 1. 1 times 3 is 3. Add those, get 0. 3 times 0 is 0. 4 times 3 is positive 12. That's 0. So now I have x squared plus 4. This would be my x term. So I have x squared plus 4. Set it to 0. X squared equals negative 4. Take the square root. And we would have x equals plus or minus 2i. Now another possibility here that you might be thinking is, nope, that would be the best possibility, actually. My brain's getting tired. So we have plus or minus 2i plus the x equals 3 that we discovered up here. So there's our answer. Okay? One more problem. This is one of my favorites. Be prepared. I love this kind. We've stretched our brains with walkways around pools, building boxes, all sorts of fun things with these. I want you to be very, very comfortable with them. If we think about the length here being x and x, then we have a height on the box of x. We have a width of the box just from here to here being, I'm sorry, that's the length. That would be 20 minus 2x. The width here would be 15 minus 2x. Now we want to find the standard polynomial. To find volume, we would do v of x, or volume, equals, we need to take the height times the length times the width, x times 20 minus 2x times 15 minus 2x. I would multiply any order here. Let's just go left to right. 20x minus 2x squared times 15 minus 2x. First would be 300 x. Last would be negative 40 x squared. Inside would be a negative 30 x squared. And the last would be a positive 4x cubed. Should come out cubic where it's a volume. Now put it in standard notation. 4x cubed minus, combine the like terms, 70x squared plus 300x. And that should be our volume. You can find it right here on B. Thank you very much. Have a good evening.